Okay, so we're talking about sine and cosine today. Do you guys remember the magic word from last year? You didn't want that. So, we're not really using this today, but I need to reference it. What did so stand for? Sine of the angle equals opposite of the hypotenuse. So this is in a right triangle, right? So if you have like an angle A, and whatever angle A is, like 34, whatever, degrees, you plug that into sine, and it spits out a ratio. And relative to that angle, this would be the opposite side, this would be the hypotenuse, this would be the adjacent. And then, so cos is cosine, adjacent over hypotenuse. Same idea, adjacent over hypotenuse. Okay, so we're not really using right triangles this chapter though. This is, we're using a unit circle. See if I can draw it well. Not too shabby. I do say so myself. So it's called a unit circle because the radius is 1 unit. So like right here would be 1, 0, 0, 1. Negative 1, 0, 0, negative 1. And kind of what we've been talking about with angles, you're going to think of these as like rotations. But if I have a line on the unit circle here, going from the center, it kind of makes a right triangle. So this is like the x, so if this is a point on the unit circle, call it x1, y1. Yeah, that doesn't look very good. Oh well. x1, y1. So from here to here, that would be like the x1 value. And from here to here, that would be the y1 value. And this would be the radius of the circle, so call it r. And how long would r have to be? It have to be 1 because it's a unit circle, so the radius is 1. It's probably hidden and hot. So on this unit circle, since sine is like opposite over hypotenuse, and here's our theta, opposite would be y1, hypotenuse would be r. So on the unit circle, y over r. And r is always positive 1. Doesn't matter which direction. Doesn't matter which direction you're taking it, r is always going to be a positive 1. And cosine, since it's adjacent over hypotenuse, adjacent is basically the x coordinate, so it'd be x over r. Okay, so sine is based off of, so it's really pretty similar. It's just up here we were thinking about it in right triangles, and here we're thinking about it in rotational angles. Okay, but pretty similar. So since sine is based off of the y value, what quadrants is the y value positive in? You guys remember what quadrants were? Which of these quadrants is the y value positive in? 1 and 2. Y value is positive going up. So what that means is, for this little equation right here, that since it's kind of based off of y, sine is going to be positive here and here. And likewise in the third and fourth quadrant, it'll be negative. So, well, what do I mean by first and second quadrant? I mean, when theta is between 0 and 180 degrees, sine is going to give us a positive answer. If we plugged in sine of 0, that would be like 0, the y value, 0 over 1, which is equal to 0. If we plugged in sine of 90, that would be y is 1 over 1, that would equal 1. If we plugged in sine of 180, we would get 0 over 1, so 0. So right here, sine is equal to 0. Get rid of these, maybe less confusing. But up here is positive, down here is negative. Up here, sine is equal to 1, it's as big as it can get. Down here, sine will be equal to negative 1, as small as it can get. Okay, and then the cosine of theta, since it's based on the x value, where is x, what quadrants is x positive in? 1 and 4. X is positive to the right. So cosine is going to be positive in these two quadrants. So that means if I plug in like cosine of 45, 45 would be like right in here, cosine of 30 or cosine of 80. It's going to be 45. Guess what cosine of 90 is? 0. Okay, because it's between negative and positive. And cosine of 270 would be 0 also. Cosine of 0 degrees is going to equal 1. Cosine of 180, or I guess you could say pi, if we were talking radians, is negative 1. So this is as big as cosine gets is 1, as small as it gets is negative 1. Does that kind of make sense? So if I throw out a random, like, what's cosine of 200 degrees going to be? Well, 180 is right here, so 200 would be about right there. It's going to be negative. Okay, or if I say what's sine of, I don't know, 400. So 360 would go all the way around, so 400 is 40 past that. So it'll be back in the first quadrant, so that's going to come out positive. You could plug it in your calculator and kind of check it, but it's just going to be positive. All right, I hope I covered everything of import. I guess I should mention, so these little circles that I drew over here are in your book on page 270. All this stuff applies even if you don't use the unit circle, like if you use a bigger circle, all this negative and positive stuff's still true. It would just, the ratios would stay the same. All right, so page 272. Number 1. Okay. I wonder if I can. All right. So it says sine of 180 degrees. So looking at this picture, 180 degrees is over here. Sine is based on the y value, and the y value is 0. So 1a is 0. Okay.
Are we grading yesterday?
I forgot about that. Maybe later. We'll see. Okay, and then cosine of 180. So, because cosine is based on the x value there, and the x value is -1 there, so cosine of 180 is -1. You could kind of cheat on this by plugging these in the calculator. I think they want you to use the unit circle, but faster to use the unit circle if you know how to look at it. Sine of 270. 270, you guys remember, was at the bottom. Sine is based on the y value, and the y value is -1. Cosine of 270. Cosine is based on the x value. The x value is 0, so it's going to equal 0. Okay, number 3. Sine of -pi. So we're switching to radians. Where would -pi be at? -180, which is the same place as 180 because they both go half a rotation. So anyway, it's the same thing as sine of 180. So sine is based on the y value, and the y value is 0. Do you guys remember if you want to plug in radians in your calculator, you have to change the settings? You probably remember that from last year. You have to change your calculator settings. Or could be still in radians from last year, who knows? Might have to change it to degrees. Cosine of pi, so that'd be like cosine of 180, so it's over here on the left, based on the x value, which is -1. Cosine of 3 pi over 2. You guys know where 3 pi over 2 would be? Or sine of 3 pi over 2? So basically it's 1.5 pi. So there's 1 pi and then 1/2 pi, so it's like 270. And the sine is based on the y value, which is -1. Doink. Notice all these are 0, 1, or -1. Okay, cosine of pi over 2. What's pi over 2? Yeah, quarter turn. Cosine's based on the x value, so 0. Okay, so number 5, name the quadrant described. So sine of theta is greater than 0, so sine has to be positive. What quadrants was sine positive in? 1 and 2. It's based on the y, so it's positive at the top. And then cosine's positive on the right. So where is sine positive, 1 or 2, and cosine less than 0, negative? Where's cosine negative? 2 and 3. So where's both of them? Positive, negative? What quadrant would that be? So So sine was positive on the top, cosine's negative on the left, so it's the top left quadrant. So on B, sine is less than 0, so where's sine negative at? The bottom, 3 and 4. Where is cosine negative at? 2 and 3. So what do they have in common? 3, third quadrant. But put Roman numerals, I guess that's a thing. Alright, without using a calculator or table, I wonder where the table's at. Solve each equation for all theta. So that's gonna, that little word all is gonna give us in radians. Okay, so where is sine of theta? Can I go ahead and erase these? You guys done with this? Where is sine of theta equal to 1 at? Sine is based on the y value. Where's y equal 1 at? 90 degrees. What's 90 degrees in radians? Pi over 2. So, it's going to start out with pi over 2. Here's the problem. It said, now that would give us 1 if we did sine of that. But what else would give us 1? Well, going that far would give us value 1, but also going that far would give us value 1, going that far would give us value 1. So if we keep adding 360, if we keep adding 2 pi to this angle, we'll keep getting values of 1. So how do I write that? Okay, where n is some integer.
It could go backwards too, right?
Yeah, n is an integer, so that means it could be like -1, -2. So it could go backwards. Technically, we should probably state that n is an integer, like it can't be a fraction, but the book didn't, so I'm not going to do it. No extra credit. Does that kind of make sense? You were adding 2 pi is like going another rotation. And if you do it 1 time, 2 times, 3 times, it's going to work. However many times you do it. Or -1 time, you go backwards, 2 pi. It works. So this is like the starting point, and then if you just keep adding 2 pi, you'll get a right answer. Okay, B is where would cosine of theta equal -1? Cosine is based off of x, and where is x equal to -1 in the unit circle? Blink right there. So it's 180 degrees, what's that in radians? Pi. But just like the last time, it's going to work if you keep rotating 2 pi. Time for a curveball. So, where is sine of theta going to equal 0 at? Sine is based on the y value. Where's y value equal 0 at? 0 and actually 180. 2 places. So, the starting place you can kind of say is 0 or 0 pi or whatever. But instead of rotating 360, instead of rotating 2 pi, you just have to rotate 1 pi before it gets to another spot where it's equal to 0 at. So instead of n times 2 pi, it's just n times pi. And now, did I need to write down 0 plus? No, not really. Just n times pi. And I said n was an integer. Do you guys remember what an integer is? No fractions, no decimals. Those numbers. If anything else wouldn't work. Alright, D's probably pretty similar. Where's cosine, or no, it's a trick question again. Where's sine equal to 2 at? The biggest sine can get is 1. Even if this is not a unit circle, since sine is a ratio, like if you turn it into a radius of 2, it'll still be 2 over 2. Still, the ratio is still equal 1. It's not possible for sine to go bigger than 1. So, it's not possible. What did they put? No solution. And it doesn't get smaller than -1. I guess I could put the symbol. Eight is pretty similar to what we did. C is pretty close to the C we just did on number 8. Not exactly the same, but it's close. Alright. Number 9. Without using a calculator or table, state whether each expression positive, negative, or 0. Okay, sine of 4 pi. So where would 4 pi be? Actually, I'm going to erase this. We can see that. Yeah, we see that part. Where is 4 pi at, like, how many rotations would 4 pi be? 2. So 2 pi is 1 rotation, so 4 pi is 2 rotations. But either way, you end right there. And it was sine is based on the y value, and what's the y value right there? 0. Okay, B, where is 7 pi over 6? Well, 7 over 6 is like 1 and 1/6. So it's a little past 1 pi. Okay, 1 pi is out here, so 7/6 pi will just be a little bit past that. So it'll be like in the 3rd quadrant. So is cosine positive or negative in the 3rd quadrant? Negative. So they just put an N. Cosine's based on the x value is negative in the 3rd quadrant. So it's going to come out negative. Okay, pi over 4. So you guys remember pi over 2 was 90. What's pi over 4 going to be then? 45. And it's negative pi over 4, so it's like 45 degrees this way. So we're in the 4th quadrant. And is sine positive or negative in the 4th quadrant? Negative. Is this kind of making sense? A little bit. D, 3/4 pi. So pi is 180, right? It's like a half a rotation. So 3/4 would be like 3/4 of the way over. So it would be like right there. So that is the 2nd quadrant, and we're talking about cosine. Is cosine positive or negative in the 2nd quadrant? Negative. I don't know what we're going to do. It's going to be a mess. Okay, sine of 60. This might be easier because it's angles. What quadrant is 60 degrees in? first quadrant. Is sine positive or negative in the first quadrant? Positive. Actually, both of them are positive in the first quadrant. Both of them are negative in the third quadrant. But yeah, it's positive. P for positive. Okay. Cadence. What quadrant would negative 120 degrees be in? Yes. Because negative 120, so we're going backwards. It'd be past negative 90. So it must be in the third quadrant. Is, lost my place, cosine positive or negative in that third quadrant? Negative. Actually, everything's negative in the third quadrant. Elena, where do you think 300, what quadrant would 300 degrees be in? Yeah. It's between 270 and 360, so it's got to be over here. And is cosine positive or negative in that? Positive. Crystal. What quadrant, Crystal, do you think negative 210 is in? Okay, negative 210, so we're going backwards, and that's more than 180. So it'll be more than halfway, so it'll be up here. So that's second quadrant, and is sine positive or negative in the second quadrant? I guess I need to. 13. Alright, back to radians. Okay, so Brock, where do you think 7 pi over 4 would be?
Fourth one.
How did you know that?
It's just less than 2 pi.
Right. 8 pi over 4 would be 2 pi. So it's just smaller than 2. It's 1 3/4. Do you guys remember how to change impropers into mixed numbers? Basically divide. 7 divided by 4 is 1 with the remainder of 3. So it's a little bit less than 2 pi, so it's fourth quadrant. Is a sine positive or negative in the fourth quadrant? Alright. Kale, where do you think negative pi over 6 is? Four, yeah. Pi over 6 is only like 30 degrees, so yeah, we're still in the fourth quadrant. And is sine positive or negative in the fourth quadrant? Okay. Let's see. I keep losing my place. I should just hold it up to my face. 13, let's see. Ty, where do you think 3 pi over 2 is?
Isn't that straight?
Yes, straight down. So straight down, that's going to make it a little bit of a weird answer. It's cosine, which is based on the x value. So it's 0. If they had said sine, it'd be -1, but we just still put negative. Anyway. Alright, Cooper, where are we at? Cosine of pi over 3, where would that be at?
First quadrant.
Yeah. Pi, remember, is 180, so it's basically 180 divided by 3, which is 60. So that's still first quadrant. Is cosine positive or negative in the first quadrant? Alright, I guess we're back to cadence. Cadence, what quadrant is 89 degrees in? Is it positive or negative with the cosine? Positive for every first quadrant. Elena, where's 91 degrees?
Second quadrant.
Positive or negative for cosine?
Negative.
Crystal, where's 720 at? 720 is 2 360s. So do you know where it would? Huh?
Is it from the first quadrant?
No.
On the line?
Yes. Okay. 360, 720. So it's right on that line. And we were talking about sine. So what's the y value? 0. What is negative? Where's negative 270 at?
On the line at the top.
And is sine right there would be what? Positive 1 to be exact, but we're not going to put that. Okay, 17 says find sine of theta and cosine of theta. We're going to use some right triangle tricks here. I'm going to draw this. So notice this is not a unit circle because it says that line is going to 3, 4, which would be farther than 1. But basically that tells us that it's going 3 to the right and 4 up. So you can make a little right triangle with that. And how could I find the hypotenuse of this, like the length of the hypotenuse here? 3 squared plus 4 squared, leg squared plus leg squared equals hypotenuse squared. Do you guys remember this from last year? 3, 4. Okay, never mind. I'll just do it. 3 squared plus 4 squared equals hypotenuse squared. The most popular Pythagorean theorem question. So it's the smallest one that comes out perfect. 3, 4, 5. All right, anyways, the questions are what is sine of theta and what is cosine of theta. So you could use the SOHCAHTOA thing, like sine is opposite over hypotenuse. Here's our theta is just the central angle here. Or you could use what we talked about today. Sine is y over r. So either way, opposite over hypotenuse is 4 over 5. Cosine is adjacent over hypotenuse or the x value over the radius. So it's 3 over 5. Notice these ratios are still less than 1. Doesn't matter how big you make the circle. The ratios stay the same. Mr. Totino was playing Dancing Queen when I walked in this morning. Now it's in my head. All right. On 19, they don't give us the coordinates of that point. They just tell us the sides of the triangle. Okay, here's something a little bit different though. On 19, theta is outside that triangle. which we haven't really seen anything like that before. But yeah, that is outside that triangle. Because we're thinking of it rotationally, like this line goes this far. Anyway. So I'm probably gonna need this guy down here, right? Like how long is this? How could I find that? It's like the x coordinate basically. 13 squared minus 12 squared is 25. And the square root of 25 is 5. Something's a little bit wrong with what I wrote here. Anybody know what it might be? This is more like -5, because it's like left 5, up 12. Yeah, this will make our cosine negative. Anyway, so yeah. Sine is, okay, so you could still do like opposite over hypotenuse, or you could use y over r. So the y value is 12, the r value, like the radius of the circle, is 13. So it's 12 over 13. So this is one way in which rotations are different than right triangles, is you can get negative answers on rotations. Cosine is x over r, so it's -5 over 13. Cosine is supposed to be negative in the second quadrant. Alright, I'll probably give you guys some time to work on this tomorrow. And we'll grade tomorrow what we should have graded today.